Faraday's law of induction. The phenomenon of electromagnetic induction is a very interesting one. To make an useful device using this phenomenon, we need a mathematical understanding of it. We must be able to say how much EMF is generated and the various factors that affect the EMF. By conducting and repeating many experiments, Michael Faraday found out that the magnitude of the induced EMF is directly proportional to the time rate of change of magnetic flux. The Faraday's law of induction states that the magnitude of induced EMF in a circuit is equal to the time rate of change of the magnetic flux enclosed by the circuit. Mathematically, induced EMF E is equal to d phi by dt. This means that if the change in flux is higher or the change happens during a small interval of time, then a higher EMF is induced across the conductor. This gives us two methods to increase the induced EMF. First method is to move the conductor through the changing magnetic field at a high speed. The other method is to increase the total flux change experienced by the conductor. For that, we can use a coil of wire instead of a single conductor. A coil of wire is equivalent to many conductors connected together in series. So, the total flux linked by the coil is the sum of the flux linked by each turn. Consider a coil with n turns linked to a magnetic flux phi. The total flux linkage capital Phi is equal to n into phi. This demonstrates that with a coil with large number of turns, we can increase the effective flux linkage of the coil. Now, we can modify the equation for induced EMF as E is equal to n into d phi by dt.